Alright, let's take a look at question number 6. In question number 6, we're looking for how does the angle of negative 50 degrees looks like. A quick review is that degrees and angles starts at 0 degrees and it goes counterclockwise to 90, 180, and 270, right? And back 360, and you can even go further, more and more. Okay, so that's the usual pattern. It goes in counterclockwise when it's positive. When it's negative, it goes clockwise. Okay, so instead of going this way, right, it's gonna go the other direction, which is clockwise. So negative 50 is clockwise 50 degrees. Right, so it's approximately here, or a little bit further. But that is your negative 50 degrees. Is this line over here, and we want to look for the graph that shows this way. So it's not choice 1, it's not choice 2, not choice 3. What's left? We have choice 4, and that is the answer. Here we have question 7. It's a logarithm question, and it's changing or converting from log back to exponential form. So in order to happen, we've got to make sure the base is the same. In this case, they all have b, 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 b. That's good. Okay, and we are converting this over here into exponential form. Let's take a look at the first part. 3 log p. What happens is any number in front of the log converted back to exponential form actually becomes the exponent of p. So this just the 3 just becomes the exponent of p, becomes p cubed. Next, we want to look for the minus sign. Minus sign over here. When you convert it back to exponential form, a minus is the same as a division, so it's getting divided by. Now, inside the parentheses, that means this entire part over here is going to go to the bottom. Okay, it's going to be underneath this big division sign. Okay, so again, any number in the front, 2 is going to be the exponent of the value there of t, so it'll be t squared. A plus is going to become a multiplication, so it's t squared times, and 1/2 is going to be exponent of r to the 1/2. Okay, we're not quite finished yet. Just want to point out that r to the 1/2, another way of writing exponent 1/2, that's equivalent to the square root of r. Okay, so we have t squared times square root of r as a denominator, and the top remains as p cubed, and that is choice 4. Whoops, sorry about that long break in between. I forgot to press the pause button. Let's take a look at number 8. Okay, it says which equation has a root where the sum equals to 9/4 and the product is equal to 3/4. Okay, for us to solve this question, we actually need to know the formula for sum of roots. Sum of roots is negative b over a. And the product of the roots, the formula is c over a. Now you got to memorize this for the regions. They would not have this on the formula sheet, so make a note of it somewhere and just keep on repeating or writing it until you remember what they are. In this question, they actually tell you that the sum of roots is 9/4. So I'm just going to put this negative b over a is equal to sum of roots 9/4. And product of roots c over a is equal to 3/4. Okay, so let's take a look at the product first. Well, if c over a is equal to 3/4, then what you can tell is c is equal to 3 and a is equal to 4. Okay, so we have 2 alphabet letters solved already. Let's try to find out what b is equal to. Okay, now let's take a look at the sum here. Well, we know that a is equal to 4 and negative b is equal to 9. What is positive b? Well, positive b, if negative b is equal to 9, positive b must be the opposite of that, which is negative 9. Okay, so now we have all the letters. We have a, b, and c, and we just gotta match it up. A is the number in front of x squared, so we got 4x squared, right? B is the middle term, so it's negative 9x, and C is the last term, which is 3. So just fix this, make this 3 equals 0. And our answer would be choice 3. Okay, let me make some room here and erase all this. Okay, next we have a absolute value inequality question. To solve this question, you have to break it into two scenarios, right? And we'll separate into two scenarios. The first scenario is you're going to have the equation, you're going to solve for x, right, without the absolute value greater than 1. And let's solve that first. We can multiply 3 on both sides to move the 3 over to the right. And we'll have 4x minus 5 greater than 3. Let's move the 5 over by adding 5. We got 4x greater than 8 divided by 4. And you have x is greater than 2, right? So we solve this. Any number greater than 2 is going to make this inequality true. Okay, the second scenario, let's take a look. You're going to have to rewrite it with the left side remaining the same without the absolute value. And the signs here, see it's a greater than sign over there, we're going to have to flip it and make it a less than sign, and also negate, right, make negative everything on the right side. In this case, we just have a number 1, we just want to negate this 1. Usually if there's more, then you have to negate everything, okay? And now we set it up, we're going to solve for x on the right side. Alright, so we're going to multiply by 3. Alright, so move the 3 over, we got 4x minus 5 is less than negative 3. Let's move the 5 over by adding 5. 4x is less than 2. Divide by 4. You have x is less than 1/2. Right. Now let's take a look at the choices. We should look for a number line where x is greater than 2 and also x is less than 1/2. Okay, so looks like choice 3. Okay, this is 1/2 over here. It's greater than 2. That is choice 3. A quick recap on dividing inequalities. It's not the case here, but if you need future reference, let's say we have questions such as negative 2x is greater than, let's say, 6, right? If you want to solve for x, anytime you need to divide or multiply by a negative number, in this case we need to divide by negative 2 here, each time you divide or multiply by a negative number, you need to flip the sign or change the sign. So in this case the answer, instead of greater than, will be less than negative 3. Okay, just a small reminder there in case this question comes up in the future. Okay, number 10. Okay, we have right, this one over here. Okay, a lot of x and y's, and we want to simplify this. There's a few ways of actually doing this. One way is when you see any number or variable to the negative 1 power, to any negative power, you can always change that negative into a positive by flipping it or changing the row from top to bottom, or if they are in the bottom, change to the top. So you can rewrite this as, and I just want to get rid of all the negatives, so you got negative 5 here, negative 1, and negative 1. So you can rewrite this as y to the 4th stays the same, 3 stays the same, but the x to negative 1, you can put that negative 1 and change the positive by putting the bottom. The x to negative 5, you can put on the top, and y to negative 1 you can and flip it and change rows to the top. Okay. Now from here you can multiply it out. Got y to the 4th times y first. You combine them, and that's y to the 5th. And we also have x to the 5th divided by 3x to the 1st. When you divide x5 and x1, you subtract the exponents. That's x to the 4th, y to the 5th, and 3 never went anywhere, so it stays on the bottom, and the answer here is choice 1. Alright, question 11. They want to find out which one of these graphs represents the function log log base 2 x equals y. So you can actually graph this out on the graphing calculator and see which one looks similar to it. So to our graphing calculator, let's turn it on. Okay, go to the y equal sign, and we're going to type in log base 2 x. If you have the TI-84, there's actually I think the updated software allows you to type it in a lot more easily or more efficient. In this case, we're going to do the old school way, and the way you type this in is press log x, close parentheses, divide by log 2. Okay. So we have log x, and then you divide by the base 2, which is log 2, and that's equivalent to this. So let's graph it out, and I'm going to zoom, just go to zoom standard, just want to see the regular view so I can see everything. And it's a a log function graph that goes like this, right? And it curves to the right, and that is choice 1. So let's circle choice 1. Alright, next, number 12. We got a circle is drawn to represent a pizza. So we got a nice, yummy pizza. It's kind of a deformed circle over here. Diameter is 12 inches. So from edge to edge, crossing the center, that is 12 inches, right? The circle is cut into 8 congruent pieces, right? So let's split this in half. Another half here, another half here, right? Perfectly sliced, 8 congruent equal slices. And they want to find out what is the length of the outer edge of any one slice, right? Any one piece over here. So let's just pick over here, okay? So let's try and find the measurement of that. Okay, well, if the diameter is 12 inches, then the radius from the center to the edge here, that must be 6 inches, right? And since the entire circle is 360 degrees and we cut into 8 perfect slices, so each slice, the angle should be 360 divided by 8, and we can find the degree of each slice being 45 degrees. Each slice is 45 degrees. All the answers here are in radians, so we gotta convert this into radians. You can take 45 degrees times pi over 180, and that's how you convert into radians, and that simplifies to 1 over 4 pi, or pi over 4. Okay, so that is the measurement of 45 degrees in radians. Next, to find the outside over here, we need to apply this formula. Is the arc length formula, and that is, and let me write it over here. That formula is S equals, right, angle R, okay, times radius. Okay, so the arc length is equal to the angle times the radius. The angle we know is 45 degrees, or pi over 4. The radius is 6, right, and that's equal to the arc length, or the outer edge. And so that's equivalent to 6 pi over 4, which reduces down to 3 halves. And that is choice 3. Okay. Okay, I'm going to pause over here. If you want to continue, just check out the next video, which will start at question 13. If there's any comments, please comment below and subscribe to get the latest videos. Thank you.